Okay, let me firstly take this opportunity, and obviously I would like to take this opportunity to thank the leadership of NSTF and its part for making a platform like this available. We know very well, since I've joined at the beginning, then I learned a lot, even though I was having the problem with the network, but I would obviously go to the website and go to the event, so as I would learn more. Engagement such as this are significant. It is a privilege for me as an educator to engage with professionals such as you. I am certain that each one of you knows the importance of the teacher. Obviously, I'm a maths and science teacher and also a private tutor, running also an upgrading center and a boarding house where we assist learners with maths and science. So I always work with the kids most of the time. However, today I'll be not teaching, but rather invite you back to the classroom environment for the moment. Okay, moving to the next slide. Basically, what I want to look at for now is the role of the teacher in advancing maths and science. The first thing that I decided to look at is what we call the duty calls. We have been tasked with an amazing task, which is to produce the future leaders, and the word changes. As we know that our country is still a developing one. So which means us as teachers, basically we have tasked to say we have to produce the young leaders and the people who obviously change the world, as I have indicated that we are still a developing country. So us as the teachers, we are a catalyst of change, the progress, and the future communities. Our role in our society is very important or vital to say, but the question is, do we recognize the importance of what we are or we do as teachers? It is up to us, colleagues, to recognize our worthy and begin to appreciate what we do as teachers. And moving to the next slide. Now I'll be looking at on hand on the desk, teaching and maths and science, the problem. I just want to look at the problems that is there on our maths and science, of us as teachers for maths and science. The problem that we have in maths is a declining numbers. Learners are not motivated to study maths and science due to the high percentage of learners failing this subject. Declining, as I've indicated, that learners are not motivated, but it's all lies on the fact that we still have a stigma of saying these two subjects are very challenging. In fact, learners, they go to this stream having the idea of, or the understanding or the stigma to say these two subjects are very difficult. Even us as teachers, we also indicate that to say no. If you go to maths and science, there are very few chances that you would make it, of which we have to motivate them to say. So, but what I was indicating is that we have a problem of declining numbers. And another problem that we have is numerical one. Over the past 5 years, significantly less than 50% of matric final exam writers wrote mathematics as a percentage. So that indicates that most of our kids, they now go to math lit other than going to maths core, and others, they also go to technical maths and technical science as well. And another problem is that the pass rate. In 2018, for example, out of 270,516 mathematics writers, about 37% who managed to pass with 40% and above, of which we say those that got 40% above are the one that they can obviously go to the varsity, even though we know very well that the competition is very high out there. Even if you can score level 3, which is 40% and above, is not enough. In order for the child to go to the university, at least he or she must score level 5, level 6, or level 7. But to be in a safer side, obviously, is to score at least level 6. And another problem is the cost. Maths has a lower, or the lowest output of the subject, classified as a gateway subject. And these are subjects considered critical to economy and development. And then now, what I'm more concerned of is of finding solutions. So now let's look at the solutions. All right, bidding from ground up. Currently, I'm raising a fund to build. The idea is that learners need to see formulas from textbook coming to life at lab. So when, for example, you go to rural schools, not the model C schools, they have a problem to say they don't have laboratories, of which whenever they are learning, they have to go for the theory instead of making everything more practical. That's why then I decided to say, no, if I can have this mobile, then I can go to different schools, because that is what I normally do. I visit different schools around KZN, even to other provinces as well, this coming, in order to move away from the fact that, yes?
Yes.
Sorry, you have your hand up, HP.
Okay, Dr. Nias, can I maybe a last question for Dr. Sibiya?
Yes, sure.
Okay. Thank you, Dr. Sibiya. Thank you for this wonderful presentation. I'm really motivated, because now currently I'm a doctor in education student, and then my main focus is now I'm studying the teaching of physics now using mathematics knowledge, which is my main research. But now the problem that now I've just come across is that now most of the schools, majority from now the research that I'm currently under the University of Central University of Technology in Free State now, and my research was mainly based in Free State. But the biggest challenge that I've come across and then realized that now was getting teachers now for professional development or self-development, as per se, due to the fact that now majority of the schools now find that now they have only one size teacher for the whole school from grade 10 to grade 12. So the teacher now and the department and the government now, they now instructed the teachers now to do the extra lessons for the learners in such a way that now for these teachers now, their classes are running from Monday to Sunday, which means they don't. So if we try to do some workshop for these teachers now, it becomes a difficult, it becomes a challenge, because now their priorities now to look at the learners. And this, most of the teachers have impacted that now. It's becoming such something like a heavy load on their shoulders, because now they don't even have time to prepare, they don't even have time to rest, they don't even have time for their families, they don't even have time to develop themselves. Like now they cannot even register for postgraduate studies based on this kind of now the work. So I wonder if now you could advise us to a strategy as to now how we can now make an intervention as now tertiary institutions, the Department of Education, and all the possible stakeholders, how to alleviate this now heavy workload. Because if you go to most of now the tertiary institutions now, try to look at now teachers who are involved in postgraduate studies, we find that now it's only about now maybe less than 2% or less than 5%. And some of them, once they get now this postgraduate qualification, they leave the teaching field, they go into academic, into universities for that. So I wonder if now there's a strategy that now maybe we can utilize now to improve now this situation. Thank you, colleagues.
Dr. Sibiya, do you want to respond to that question?
Yes. Yes. In fact, I think that the last line where the guy was indicating that the best solution obviously is to move from to try to go for the visual classes, because that assists to say, as was indicating, that it is very difficult to say to teach almost like 7 days in a week. However, if, for example, we can have like the recorded lessons, I think that can assist a lot. So basically, to say moving to the visual classes, it normally helps. You know, what I'm working on, as I indicated, when I'm talking about the visual class, I normally go to different schools on weekends. But now I've said no. I find it very difficult for me to go across the KZN to teach. But however, if I can have a class whereby I can simply sit down and just project to different provinces, to different schools, whereby the school can simply just open the TV the screen, whereby they can just watch the lesson, of which that can make everything more simpler, other than teachers going to schools each and every day. One can say, if maybe like the Department of Education can say, let's say in a certain district, then there is a center whereby the kids can simply go there to watch the lesson that is being conducted by one teacher. That can assist a lot.
Okay, well, thank you. Yeah, it makes a very significant meaning to the changes that we see.
Okay. Okay. No.
Okay. Thank
Yes.
you, Dr. Sibiya, for that answer. Please continue.
Oh, okay. Thank you so much. Then I was saying, what I normally do, I normally create the conducive environment whenever I'm teaching, because the conducive environment allows learners to feel free, to feel at home. This also allows the learners to interact during the lessons, because most of learners are bound by fear to ask questions or to seek clarity on the topic. Therefore, the relaxed environment accommodates them all. I receive even calls from parents to say, no, my child, the problem is that he is always afraid to ask the question from the teacher, because other learners, they normally laugh when one child is asking any question. However, if the environment is more conducive, they would feel free to ask any question. Even if you are a teacher, making sure that you are creating that. That's why I ended up saying, as a teacher, you need to be approachable. So if you are approachable, obviously, it will be easy for all learners to ask any question. Right. When we teach, we must focus more on skills per question instead of answering the past papers. It's one of the problems that we are facing in teaching mathematics, that most of us as teachers, we focus on past papers instead of looking at the skills or the cognitive level, or let me say just the skill that is being asked by that particular question. So if we can move away from that, I think it would be easy for us to make these kids to excel in math and science, to say. So what I normally do, I create the summary note, which focuses on skills required to answer questions. And with that summary note, I share them with all learners across the country, and they are getting those summaries for free, because what I understand is that they don't have to focus on the past papers, because you can even find out that one of the child can just do the whole paper for the night, but when the exam comes, the child still fails, because the child was just answering the question paper as if it is something that will come up in the exam, of which whenever they are using the past paper, we have to always teach them to say, when we are answering the question paper, what is it that we are doing? It basically is to indicate the skill that is needed by a particular question. So as at the end of the day, you would have the summary of those skills that are needed in answering any question. So whenever I'm answering the past paper with them, I simply focus on the structure of the paper, not focusing on the textbook, but focusing on the structure of the paper, looking at the different cognitive levels that are there, and obviously in connection with exam guideline and the CAPS document, because that is what is important whenever we are teaching. And another thing as a solution is to motivate them. Most learners in mathematics and science give up too early, but the time they write, by the time they write their exams, they've already told themselves that no, they won't make it. Therefore, what I do in this case is to show them how easy it is for one to pass mathematics. What I normally do with them, I simply indicate to say, for example, if we take mathematics, we have plus or minus 10 questions in a paper. So if one can score just 5 marks in a question, to say question 1, 5 marks, question 2, 5 marks, question 3, 5 marks, up to question 11. So basically they need only 45 marks out of 150 for them to pass maths. I'm talking about one passing mathematics, not about the level, because we know very well that even if the child can go level 2, but that does not mean that the child will go to the university level. But what we have to discuss with them is that in order to pass, you need only 5 marks, of which it's very easy for anyone to score 5 marks per question. Right, so that is what I normally tell them to say. We're not discussing the fact that you would pass or you'd fail, but what we are discussing is that which level you will get. Therefore, we look at the entire and the narrow focusing on the 75%, which is on the exam, to say, even if, as we speak now, they're about to write, however, whatever they were doing from the beginning of the year up to now, it would only contribute 25%. So of which the exam will contribute 75% of their final mark, of which it is very possible for any child to change or to pass at any given time, because for the one to pass the exam, he or she must excel in the final exam. So that is what I normally do. So to say, I always motivate them, right? And I ask them to set their target, because if, for example, the child is targeting level 4, it will be easy for the child to work according to his or her target. So that is what I normally do. So also dismantle the fear that this subject are difficult. So that is what I normally do. And whenever I'm teaching, I make sure that they are involved. I get them involved in the lesson. I also allow them to participate in class. They also do presentations. And when they are doing presentation, what we normally do, we correct the misconceptions, because when they are presenting, that is easy for me or us as teachers to identify the misconceptions that they are doing while they are presentation, or why they are presenting to say. Learners get practice under our supervision. We look at their skills in answering questions. Once they get it right, then they would never forget it. So that is what I normally do. Specifically the one of presentation, because that is where I'm in a position to look at the misconception, and even those that they are listening or observing one presenting, they will be in a position. I always even allow them to say, can we correct any misconception that we have identified there? So if we all discuss that misconception, then it will be easy for all of them to not repeat the very same misconception that they have identified. All right. And moving to the next slide. What I normally subject are difficult is integrating social trends. That is another way, which have helped me produce the high number of learners who excel in this subject. Basically is one that I'm indicating the social trend. What I normally integrate is the sport. I know that most of the kids, they like sport, they like music. So whenever I'm teaching using sport, using music, then they tend to enjoy my lesson. So mathematics and science is all around and is in us to say. We all the result of science, therefore no need to look any further for answers. So I usually turn the formula, or let me say the science definition, if they have to define, for example, the acid, to say the acid is a proton donor, we allow them to sing the definition. So as even if that definition comes into the exam, they will find it very easy for them, wide writing inside, then they would sing wide writing the definition. Even in calculus, when they have to calculate the turning point, then there are some steps that they have to follow. What I normally do, we sing those steps of determining or of calculating the turning point. So then I find it very easy for them to recall why they are writing the exam. Even when we talk about soccer, as I indicated, that most of them, they like soccer. If I take the sign of the bigger teams, like for example, if you check Orlando Pirates, then we have a cross bones there, of which it's more of the cross multiplication. But even on top of that, we have vertical opposite angles there. If you add all the angles around the sign of Orlando Pirates, the section there, they would add up to 360. So when they see the sign of Orlando Pirates, they would see mathematics, they would see vertical opposite angles, they would see cross multiplication. And again, if you look at Sundowns, it's like a 7 shape. However, the angle between two fingers is 90 degrees, of which they can be asked to say, can you prove that this angle is 90 degrees? So they must know that the two lines are perpendicular, which means the product of those two gradients, obviously they would give us -1. So they found it very easy to record in the exam. And if we look at the sign of Kaiser Chiefs, the sign of Kaiser Chiefs, then I relate that one to angles when we talk about the cosine rule, whereby we say there will be an included angle. We talk about the side angle side. So then when they see the sign of Kaiser Chiefs, obviously they would relate it to cosine rule or area rule, to say, because that is what they always work with when they are dealing with trigonometry, to say. And that is what it has been working for myself. Even then, even if there is a free period, they always make it a point that they come to me to say, sir, we have a free period, can you come and teach us? Because the way in which I'm teaching, then they like it, because it has to do with what they normally see on social networks, what they normally see in their lives, to say. Right, and another thing that is working for myself is to separate and schedule. At the beginning of the year, I separate them according to their capabilities. To say those that are scoring between 0 to 30, 30 to 40, then I separate them at the beginning of the year. And I also put those that are in the middle and also the high flyers. Right, and now, when I'm conducting these extra classes, I normally don't ask them all to come into the morning session, but what I simply do is that I take the group of those who are struggling with mathematics, so as I can move them from level 1 to the next level, to say. And if I'm working with those that are my high flyers, I'll know when I go there that I have to come with the level 3 and level 4 questions, because they really need something that would keep them on the higher level, to say. So that is what I normally do. So it's to say, separate at the beginning of the year, and I put them in the extra classes according to their level. With that, it's also avoid learners' frustration in the class, to say what we are doing in the morning, it's very easy. Then those that are high flyers, they get bored. And if you are mixing those that are struggling, then they will see mathematics as difficult, because you will always have to also accommodate those that are performing very well in mathematics. Right, and another thing is to bring science to life. In the absence of lab, which helps us create the realistic perspective, science must be taught more practically. Have labs, if not, have a demonstration in class. So, for example, if we go to rural school, it is very difficult to see the lab there. However, as a teacher, you have to make it a point that you always demonstrate, because if you demonstrate, you make it easy for them to visualize and to apply what they are doing. But with the point whereby we said, if we can move to the visual classes, it would be easy for us, because when we are using a visual class, it will make us easy even to put some assimilations. You know, when you are teaching science, if you say to the kids, there will be a movement of charges from point A to point B. So then they have to say, how these charges are they moving? They find it very difficult if they cannot see it. However, if we can try to move everything to more practically, it would be easy for them to understand the concept that we always teach them. However, what I normally do, I normally demonstrate, try to make more practical. You see, if I even ask them to say, can you go and give me, or can you give me water there? I normally don't say, give me water, but I say, can you give me H2O? Because they have to make it a point that this, whatever is happening, they say it. When I'm talking about the parabola, I normally show them my stomach to say, you see, I have a big stomach now. So then that my stomach is in a shape of the parabola. So I always bring my teaching into life. So that makes them understand very well. And moving to the next slide. Yes, in conclusion, let us be intentional. As a science and technology community, we need to be intentional about populating our space with brilliant young minds. This means that we must make tools available for abstracting this down, because they are hidden in a rock and hard places, in a dust street of our township and rural areas. Okay, I decided to change a little bit the topic, because if I'm talking about the extraction of the dam, I'm talking about the skills that are there. I'm talking about the mathematics that is already there in the child. So however, we have to put these tools available. When I'm talking about these tools, I'm talking about the teaching approach. We have to make our teaching to be more funny, so as they would enjoy. We have to demonstrate. We have to use social trend, as I indicated, that we normally sing with them, to allow them to understand the definitions, also the steps and everything. Right. So those are the tools that would assist us to abstract this diamond from the data. And let us be more practical. That is my conclusion. The theory is beautiful because it is rich information to say. However, bringing that information to life, it's a whole new challenge on its own. You can tell somebody about the ingredient of the great dish, but the reality is the deal is what is happening basically in the kitchen. Maths and science are not different. Our kids need to see these theories coming into life. So that's why we have to make it a point that we make our teaching to be more practical, have some labs if possible, so as they cannot memorize this, especially when we talk about physical sciences. We're talking about titration, where there are some experiment, but in most of the school, we simply theorize that, of which we find it very difficult for them to understand how the process of that phenomenon is going if we simply theorize instead of making more of experiment, making more practical, so as they would understand. Lastly, hyper of our global impact. South Africa has produced some of the most amazing brains in science and technology. People such as Yabulela Letukolo Uzam, Prof Karim, Prof Shatta, and Dr. Chris Barnett, and many others, such as, have shown that South Africa's contribution to the world is valuable. Our kids need to know this and need to find and interact with such role models most often. So that is the end of my presentation. I would like to thank you all and hope that we can strengthen the net, roll our ship, and start digging those diamonds stuck in the dirty. Thank you so much for a wonderful opportunity.